All right, let's dive right into this explainer. We're going to use some seriously cutting-edge modern science to crack open one of the greatest mysteries in ancient history. We're talking about a vanished empire, an actual ghost river, and a colossal geographical plot twist that literally changed the course of human civilization. So we're starting our investigation at the crime scene, the arid, scorched terracotta sands of the Thar Desert, right across northwestern India and Pakistan. Now, if you look at this region today, it is incredibly hostile, like bone dry. Yet, paradoxically, thousands of ancient Indus Valley settlements are clustered right here in the dust, which begs the question, why on earth would anyone build a massive empire in a scorching desert? It makes absolutely zero sense, right? We're talking about roughly 1,700 Bronze Age settlements. These were highly advanced cities, places like Kalibangan and Banwali, that boasted grid-patterned streets, massive defensive walls, and super complex drainage systems. You simply do not build a thriving metropolis in a wasteland. Unless, of course, the landscape used to look completely different.
And this maps out that exact paradox brilliantly. Notice how these 5,000-year-old cities aren't just scattered randomly. No, they perfectly line up along this completely dry, snake-like depression in the sand. It's exactly as if they were built on the banks of a massive river that, well, simply isn't there anymore.
Section 1. The eye in the sky, mapping the unseen. Okay, first, we need to understand exactly what we're looking for here, a paleochannel. Basically, this is the ghostly, buried footprint of a dead river. It's a channel that's been filled in or covered by younger sediment over thousands of years, so it's completely hidden from anyone just standing on the ground. So, to solve this cold case, scientists realized they had to look down from space. By using microwave radar and optical satellite sensors, researchers were able to literally pierce the surface sand of the Thar Desert. These passive optical sensors and synthetic aperture radars, they detect subtle variations in soil moisture, vegetative vigor, and clay content. And when processed, something incredible emerged. Dark, buried river channels glowing in the data like high-tech neon blue veins, just hidden beneath the dunes. The scale of this discovery is just staggering. They mapped out a massive 1,500-kilometer continuous paleochannel network stretching all the way across northwestern India and deep into Pakistan. I mean, this wasn't just a minor creek. We're talking about a continental-scale drainage system. Suddenly, the myth of the mighty Saraswati, or the Ghaggar-Hakra river system, was physically visible. Radar topography showed that this wasn't just a flat plain. The ancient river actually formed a deep, incised valley, eroded right into the landscape, and this valley offered a massive, stable haven for the Indus civilization to build upon, perfectly protecting them from the unpredictable, devastating floods that were super common to other active Himalayan rivers. Section 2. Tracing the Smoking Gun. Underground Evidence. But was this just a seasonal puddle or a roaring glacial giant? To find out, we need to plunge underground for the hard evidence. The crucial point here is how scientists treated this like a literal crime scene, using heavy isotopic and radiometric DNA-style testing on the water and the sand trapped deep below the surface. They used cutting-edge techniques to date organic matter, measure exactly when quartz was last exposed to sunlight, and chemically fingerprinted the rocks to find out exactly where they came from. Get this. The Baba Atomic Research Center tested the trapped groundwater in places like Jaisalmer, and what they found was astonishing: 0 modern tritium. Now, tritium spiked globally after nuclear testing in the mid-20th century, so finding 0 meant this water hadn't mixed with surface rain for a very, very long time. In fact, carbon-14 dating showed this water was totally isolated, with ages reaching back over 18,000 to 22,000 years. Absolutely wild. Furthermore, the water's stable isotopes, specifically oxygen-18 and deuterium, were highly depleted, which perfectly matches the signature of high-altitude Himalayan glaciers. So it proved, beyond a shadow of a doubt, that this wasn't local monsoon-fed rainwater. No, it was pristine, ice-age glacial meltwater trapped directly beneath the scorching desert. And the sand itself held the ultimate smoking gun. You see, just like a fingerprint, rocks have specific age signatures. When researchers analyzed the detrital zircon crystals in the deep paleochannel sands, they found a massive age peak at 480 million years. That's a highly specific signature that exactly matches the Paleozoic granites found in the modern Sutlej River catchment. It proves definitively that the mighty glacier-fed Sutlej used to flow right through this very channel. Section 3. The Tectonic Heist, a stolen river. So, if this was a mighty, glacier-fed river pumping Himalayan water through the region, what killed it? Well, prepare for a massive geological plot twist. The culprit wasn't just a gradual change in climate, it was a tectonic heist orchestrated by the shifting crust of the Earth itself. The ongoing collision of the Indian plate into the Eurasian plate makes the Himalayas one of the most geologically active regions in the entire world. Looking down at the Yamuna Tear Fault, you can clearly see how intense seismic activity literally ripped the landscape apart. This acted as the gateway for the geographical robbery. The Earth physically tilted and entirely redirected the water. Over thousands of years, these tectonic uplifts effectively decapitated the Ghaggar-Hakra from its glacial lifelines. First, tens of thousands of years ago, the Yamuna was deflected eastward toward the Ganges. Then, between 10,000 and 8,000 years ago, the Sutlej was deflected to the west, eventually joining the Indus. Just like that, the great river was robbed of its ice. And this sets the stage for a tragic collapse. Step 1. The glacial sources are severed by earthquakes. Step 2. The river, deprived of its Himalayan lifeline, becomes entirely reliant on seasonal monsoon rains, which actually stabilize the river for a time, allowing the Harappan cities to flourish. But then, Step 3. Around 4,000 years ago, the global climate shifts and the monsoons weaken significantly. Finally, Step 4. Without the rain, the river dries up completely. The great Indus Valley cities are starved of water, eventually abandoned, and swallowed entirely by the advancing desert sands. Section 4. A myth made real. Science and legend. Modern science didn't just solve an archaeological cold case here. It proved a legend that had been passed down for millennia. The ancient texts spoke with incredible reverence of a mighty river that vanished underground. For a long time, this was completely dismissed as pure mythology. Yet, our modern satellites, radar, and isotopic dating proved that the texts were describing a literal geological reality. The ghosts of this 22,000-year-old glacial aquifer, trapped in a 1,500-kilometer tectonic paleochannel, are still glowing down there in the dark beneath the Thar Desert. Which leaves us with a truly fascinating thought to take away. If the shifting crust of the Earth can literally steal a 1,500-kilometer river, bury a flourishing Bronze Age empire under the sand, and turn a very real geological event into a cultural myth, well, what other ancient myths are just forgotten geology waiting to be discovered?